Alright guys, in this video I'm going to show you some underwater features, mostly marine canyons, some underwater scablands, underwater drumlins even, and other cool features. So let's start with some marine canyons. This is a really cool spot here. And you can see you've got some ravines coming through here in the general direction of this deep underwater channel, and you can see where it narrows, it's focused, and then it expands afterward. That's something fluids do, they expand and contract. And this is actually incredibly deep. If we look at the depth, is over 1,000 meters deep. So something really carved this channel deep, and ice can't carve something 3,000 feet deep when the sea level from the ice age only dropped 400 feet, 600 feet max, right? So this is something much deeper and much more powerful than some ice age erosion here. Now, how is it even physically possible for water to carve out a canyon that deep? Well, the answer is quite widely accepted that it's debris flows. So this is an example in Switzerland. This happens almost every year. When they get flash flooding, they get massive boulders and massive debris flows that rush down the steep mountainside. And you can see that these boulders here are very large, and you've got a lot of pressure upstream that's pushing all of this down. And now we see the mud flow. So the rocky front and then the mud flow after, and there's still definitely some rocks in here. But yeah, so that's basically how something like this was able to carve so deep. So where did it get all of this inertia when it's over incredibly flat terrain? Well, an ocean current would be one answer to that question. But the proper thing to do is to start with the evidence and then backtrack from there. So we know that there was a debris flow that went through here. And over here we see a fan from the debris flow. So this would be an alluvial fan. Okay, we've got more deep rutted channels, basically a fjord, which is what they find in Norway. Another little fan there. But if you really want to see some big debris fans, check out Greenland. Look at all of these debris fans. So same thing happened. There was a current that washed off the mainland of Greenland. And this right here is a big old alluvial fan. And in the center of the alluvial fan, just as you'd expect, is a little canyon. Not a deep canyon, because how this was formed, it is not too deep. I mean, it's still impressive, but it's not like the other one where it's rutted out. Because in the other one, it was focused, it was pinched. This, it expands, and it's in basically the middle of the ocean. But the depth on this is 340 meters deep, right? So that's still over 1,000 feet deep. Here's another alluvial fan. There's another one. Let's see how deep this gets. It kind of looks like it's a little more focused here. It's about 350 meters deep as well. Pretty similar. And then it feeds directly into this incredibly rutted out terrain here. This is a lot of focused erosion. So when you find focused erosion, that's from a water current. So not only is it focused, but it's very winding. It's very curvy, right? So an ice sheet is basically like a snowshoe. So if you had a snowshoe or a big block of ice and it moved off a landscape, you're not going to get tightly focused winding ruts. That's just not in the cards. It's going to follow rigid body dynamics, not fluid dynamics. So entirely different field of physics, whole different ball game when it comes to erosion. And then we've got scouring ruts that come across. They might call those glacial striations from boulders being scraped along the surface, but that's just not exactly what happened. Okay, so this is another place that has a lot of ruts, and they're all parallel with one another. It's a very cool spot. All right, that's Greenland. Let's see what this pin shows. Let's see if there's evidence here. Ooh, would you look at that? These are ruts that are coming across this landmass, right? So these are all terrace lines, right? All of these lines are like river terraces, indicating where the water current wrapped around here. Now, to really prove that they're terraces, this pin shows that these are ruts, right? These are like river ruts that come across. And I can actually show you, places all over the world that show you that. Just while we're on the topic, I'll zip over to a place in Canada. That's an incredible location for that. And there's also a good one in Alaska. So if I believe it should be, don't have this one pinned. If you'd bear with me a second, I'll find it. All right, see how this one's streamlined? So now we're getting close. We're finding streamlined features. Where are you? Come on. There she is. You see this beauty? Big old streamlined feature here, that nice U shape. And then let's look at this. We got river channels not going downhill. Why aren't the river channels going downhill? That's what you'd expect a river channel to do. Instead, they're wrapping around. See this? They keep wrapping around the streamlined formation. Okay? You see the channel keeps going. Let me give you one more example. Let's go to Alaska, right here. Okay. This is also a streamlined feature, same thing. And we zoom in and we find ruts wrapping around. Not going downhill. The ruts don't really care about going downhill. They care about wrapping around the formation. It's a streamlined feature from an ocean current. Okay. See these ruts? They keep going parallel. So when you trace the ruts wrapping all the way around something, that's a second verification that this was streamlined. Okay. And there's a lot of streamlined features in this area. For example, this thing here. This here. Okay, let's go back to marine canyons and underwater features. Let's talk about underwater drumlins. That's a pretty cool feature. So you would, apparently a drumlin is from an ice sheet moving across, right? Basically a drumlin is a straight lined mound of sediment. But here we find drumlins. Or actually these might be underwater ruts. But either way, they're both, it's either the negative relief, which would be a rut, or a positive relief being the drumlin. But either way, they're the same feature, both made from a sheet water flow. Now let's check the depth of this feature here. This is 150 meters deep. So multiply that by 3.28. That's going to be, let me just do that real quick. See what we got here. 150 times 3.28, 492 feet. So this is very deep. And it's in a lake, it's not in the ocean. So how did this get undercut to form these ruts? Okay. Now we go here, we can follow a channel. St. Lawrence River occupies it now. But then we can keep going through this channel. We see how this was carved out from this direction. We find this being a streamline. This is like a gravel bar streamed out from a river. Find a little shallow cataract coming off of here, another shallow cataract making a cove feature. Goes offshore. And let's just keep following it. Now we can see an underwater channel. Let's get a width on this guy. In miles, 56 mile wide channel that continues and goes right off the continental shelf. And the depth of this guy is only about 42 meters deep, so it's very shallow. But it's a 50-mile wide river is no joke. Some serious erosion. And then check out this marine canyon here. All right, so this was formed from a debris flow / mud flow. In order to carve so deep, this is 2.4 miles wide and 4,400 meters deep. So it's over 10,000 feet deep. Let me just do a little calculation because meters don't mean that much to me. American times 3.28. Yeah, this is 14,000 feet deep. 14,500. So yeah, now we're talking about some deep water canyons. Let's follow this guy. We can see we can actually keep going down this way. This is the last clean section of it we can find, but we're going to trace this guy. And we're going to just estimate it probably wrapped like this. It's something like this. Came through here. Find it here. Nice curve. The curves really indicate, a river flow. Now what's cool about this spot is here we see terraces, right? An outer bank and then an inner bank. That shows where the mud flow decreased. Very interesting. I love it when we see terraces because that just gives us more evidence of, exact evidence of its width as it decreased. So it was once a large flow that then decreased in stages, and we can actually visualize those stages. Now we don't really see it for very long or anymore. We can see, I think this is it here. See if it lines up. Yep, it lines up with this little guy there. Let's zoom out, see if we can trace it. Now it's all blurry here, but we can still see it's actually pretty straight right here. Oh boy, we're over 1,000 miles. This ain't no joke. Let's keep going. And we can follow it all the way up to here. Now that's where it hits the continental shelf, where it flowed off of. So check that number out. Almost 1,400 miles. So when I showed you the debris flow, this is a pretty serious debris flow coming down the Swiss mountains. But just imagine one that traveled 1,400 miles deep underwater. And from the angle we see here, it lines up with this rutted out terrain. We see a channel that completely crosses the landmass, right? So when we see a channel that completely connects across the landmass, we can assume that a water current flowed completely over the landmass, right? It's a very simple observation. Also went through this way. And then we got these really nice scratches here. These are really nice parallel ruts. Now, water can form parallel ruts when it's moving very swift. When it slows down, then it tends to meander. So when you find straight-lined river ruts, you're talking about a swift moving current. Okay. So that's really cool. That's one of my favorite marine canyons in the world. Another one's in New Zealand, which just makes no sense. I'll show you that one after I show you this terrace section I really love here. So check this out. This is the most terraced marine canyon I've ever seen. Let's get a width on it. 5 miles. Okay, 5 mile wide debris flow. 3,600 meters deep. But not only that, we know for a fact this is telling us exactly how this mud flow decreased. It's telling us exactly at one point in time it was 5 miles wide. Then it also tells us exactly at another point in time, it was 3 miles wide. Then it also tells us it was exactly 1.65 miles wide. So all of that information, all of those data points are telling us that we had an extreme mud flow that then decreased in stages. Anytime you have a river that floods after a rain, anytime you have a flash flooding event, you're going to find a river that looks like this. It starts off very wide, decreases in stages. So people love to say, oh, uniformitarian, blah, blah, blah. You cannot say that if you understand terraces and how they decrease. This right here absolutely proves that these marine canyons were formed in a catastrophic event that then decreased. Okay? Don't forget that. And this whole canyon here is insane. It goes you can't track the whole thing, but it probably goes 1,000 miles offshore. But I want to talk to you about New Zealand, because the idea of a marine canyon forming off of such a tiny landmass is quite interesting, because you would assume there'd be a correlation between the larger the landmass, the larger the debris flow and the underwater canyon. But the landmass here, it's only 150 miles wide. So it doesn't really have anything to do with the size of the watershed. What it has to do with is steepness and the power of the ocean current, because it's the ocean current that eroded this landmass, and that erosion then flowed down into the debris, into the marine canyon. So we got a 150 mile wide watershed, or the length of the watershed is 150 mile wide. We can see all these branching and kind of coalesce to form a nice marine canyon. But let's do a length check on the marine canyon off of that landmass. So now we're already over double the width of New Zealand. We keep going, 500. We can see it makes a sharp right turn, comes through here. It's a little blurry, but you can still track it. Here's our best little piece here. We can see a nice canyon here in that strip. Then we can see it over here. And over here. Right, this is it here coming around. It's kind of hard to see. I've tracked this one around here. It gets really blurry, but this also looks like it's part of the canyon here coming through here. But if you want to give it a conservative estimate, you could just end it here where we see our last clean piece, right here. And that's at 700 miles offshore. And the last time we see it, it's over 1.8 miles wide. So, I mean, just think about, the Columbia River, a lot of places, it's less than 1.8 miles wide. So this is an insanely wide river that's almost 5,000 meters deep. And it obviously keeps going, probably goes over 1,000 miles. So you're talking about an incredible amount of debris flow and inertia. And another thing is you have a consistent chain of pressure. So when you have a debris flow coming off of here, what pushes the debris flow forward across this relatively flat terrain is the debris flow behind it. It's like a chain of pressure. It's like a train. If the engine's in the back, right, that's what pushes it forward. So same principle with these marine canyons. Here we find another one. So this is an insane gap right here. This is what would you call that? A channel, a strait, like the Strait of Gibraltar. Kind of looks like the Monterey Canyon. So you got an insane canyon here, right in a gap between the land masses. And we're going to start it right here where it really gets serious. And we're going to get an idea. We're going to follow its curves a little bit just to really see how long this thing is when we can accurately measure it. Wow, here it looks incredibly wide. I'll measure that on the way back. Over 100 miles already. It looks pretty windy here. Just going to estimate it. Keeps going. Keeps going. And we can't, is this the last, oh no. Makes a turn here, and then we can follow it through here. Keeps going. Keeps going. Still blurry, but you can still tell that's clearly the Marine Canyon. You can see the curves in the canyon. And let's see how far it goes. Here's another good curve we can really indicate it's a canyon. And I think that's just about the last time we see it. So it's almost 800 miles. And there's no landmass here, right? So if there's, yeah, that's the funny thing is there's literally no landmass here. There's no watershed. And yet we have a marine canyon 800 miles offshore, right? So welcome to catastrophism. All right, marine canyons, you can't really talk about them accurately if you're not talking about catastrophism the whole time. So marine canyons, definitely one of my favorite features. But let's check out this right here. Wow, this is a wide marine canyon. You can clearly see the bank. And let's get a width on this puppy. 6 miles wide at 2,600 meters deep. So I'd find that impressive. All right, let's see what other cool things we can find around here. So on coral reefs all over the world, you can find scablands. Okay, so these are, the reef was formed and then you get all this pitting on it. This is the exact same type of pitting and scabland features that you find in Washington or anywhere you find scablands. There's a cool spot I want to show you. As soon as I find it. Ooh, this spot's actually pretty sick. Look at this feature. Now, what is the makeup of the geology around here? Well, it seems as though there's some layers of geology, but then this is, you know, a cataract feature, so water came off here to carve it, and then you have differential erosion kind of carving out these pieces here. So that's a really cool spot. This is all scablands, right? And if you don't believe me, then just follow the river channels. And you see, oh yeah, I guess that is a river channel. So the river did carve out this. And then this here is the cataract, right? So you got a river in the center, cataract, right? Cataract's basically the feature a waterfall makes, but a waterfall makes that U-shaped pattern. So I just call these shallow cataracts because it's the exact same principle of formation, just on a shallower scale where the water doesn't actually free fall. That's the only difference between a cataract and a shallow cataract is the water free falled in a real cataract. But coves around the world, yeah, are all, anytime you find a cove, that's a shallow cataract. Water comes through that channel. Here we find a really cool accretion ridge. Or is it just a parallel river rut? Well, because it's made out of something lithified, it's a parallel river rut, not an accretion ridge. Yeah. So look at all this streamlined features. Really cool spot. And then these are all, you know, from an offshore current, carving out these perfect little coves. let's see if I can show you. Oh, here it is. This is a, oh wait, I already showed you. This isn't it. Maybe, where is it? I mean, you look at any of this and you can see the river channels. Really, all of this is river channels. I think I gotta go over to here. I literally went back to the same spot, didn't I? Impressive work. So you guys can see, this is all underwater scablands. Actually, Australia's got a really cool spot. Here you can see how the water just swept through here very swiftly to make these straight lined features. So the ocean current once moved really fast. That's what that tells us. Yeah, this is a spot here. All of these potholes and scabs, scours. Yeah, so this is an incredible place to dive. If you're diving in these spots, just know that was all carved out by the ocean current. Just like the Oregon Scablands, Washington Scablands too. Nice little marine canyon. This one's pretty robust. Let's get a width on this guy. You can start from the top to the top. 11 miles, dang. Yeah, very robust. And then where does it come from? Really perfectly flat terrain. So, and then we find a little bit of, you know, salty river channels. I wonder what that indicates, right? It's a real head scratcher, I know. Let's see what this is about. It's a pretty lame pen. You know what? I'll show you this cool spot in Belize, I believe. Is it that one? Yeah. More underwater scablands, very interesting. This is one of my favorite spots. Look at this channel, right? Just so beautiful. Just absolute artwork. The way the ocean current carved these out. Absolute artwork. 1 mile. Now, I actually want to show you this here. This is pretty baffling. You guys are going to be confused by this one. Really in the middle of the ocean, right? You couldn't get any more away from a landmass. Right, completely away from all the land masses. Why the heck is there a marine canyon here, right? See the winding curve of this marine canyon? What is it doing? Oh my gosh, they're all right next to each other. Look at this. Too bad they're all blurry, but these are just marine canyons all over the place. So, yeah, that's it's a real head scratcher. And then we get these parallel lines here. These look like fractures from the seafloor tectonic forces. So we've got, but here's the ridge here, right? So seafloor spreading. This is basically the rift here, and then you've got all of these fractures that come off of it because it was, breaking apart and moving in a very messy way. So this is the mid-Atlantic, or not the mid-Atlantic, whatever ocean this is, it's a rift here. So that's what these lines would be a part of. But then you've got the marine canyons. Those fracture lines don't curve like this. They don't make, these are clearly marine canyons. So just want to let you guys know about that. Let you guys scratch your head on that one for a few days. And seafloor spreading went through here. Yeah. Little marine canyon coming off of here, off of also very flat terrain, but a terrain that shows a lot of water current nonetheless with all of these drumlins, and then these ripples perpendicular to the drumlins. So there you have it, the erosion of the earth. Thanks for watching. Please like, subscribe, share. I appreciate all of that. Thank you very much. Goodbye.